I'll be just talking about technology component on how we are monitoring it, how the reporting system works. I'll confine to 10 minutes to show you about what is happening in the open ocean. This, we are talking about this particular day, important day. It's 16 years ago. This is a particular series of pictures we had it. A few of my colleagues, they were in Hudbay. They had gone for a coastal pollution monitoring program on the fateful day. They were there and they were trying to, they were having a morning tea, and the vessel was supposed to sail out from Hudbay to Port Blair. And this particular instant, they didn't know that tsunami struck, but the waters decided, where a thoughtful ship crew, he cut the mooring rope and the vessel started drifting away. You can see the series of pictures. It's the first time I'm showing. I've not shown to anybody else. I saw this as an opportunity for us to understand. And until they reached Port Blair, 8 hours, they didn't know that there was a tsunami struck and many people died. The place where they were having morning tea, that got washed away. This is another point to show you the importance. This is the southernmost tip of India that does not exist now. Now, when you talk about 2004 to now, what type of technology development has happened? And the important point is tsunami early warning, which Dr. Srinivas has presented. INCOIS and our Minister of Earth Sciences have done a very good, wonderful job. And we need an important part is how do we do the tsunami detection and forecasting process. There is a DOT technology that is called Deep Ocean Assessment and Reporting of Tsunamis that was well established by Pacific Marine Engineering Laboratory, NOAA. So we borrowed that initial technology, and this need to be established in the open ocean. How does it work? We have three types of waves: wind-driven and tidal waves, which we normally see in the wind waves are seen in the beach. The tsunami waves are long waves. The pressure could be felt from surface to the bottom, whereas first two waves, wind and tidal-driven waves, the pressure cannot be felt. So simple physics, this was thought over it, and what we do in the right side, we install a system at 4 kilometer depth approximately, and it starts monitoring continuously every 15 seconds the pressure data using a very special pressure sensor. Many of the students, they know about Borden tube pressure gauge, and that starts communicating. Now, the challenge for us is underwater communication is only by acoustic. It has to pass through that, and it has to go through the satellite, which is 35,000 kilometers above in the geostationary. It should reach our office. We always say that any electronic components or a system can hang over there, or it can have a malfunctioning, and the whole system need to be installed about 1,000 kilometers away, far away, close to Nicobar, and that need to work throughout the year because we have a limitation going to the site. We can reach only once. But we have mastered this initially installation component. We need to install the bottom pressure recorder separately. We need to install the mode buoy separately. The communication angle underwater is only 30 degrees. Within that level, the communication should take place. So you need a gamut of techniques and expertise to install such a system that should last about 10 years. We've been working more than about 250 times. We would have installed, never there was a failure. Typical sinusoidal curve, what you see is a way the pressure variation takes place. When there is a tsunami event, you can see at the topmost picture, this is a continuous amount of rapid mode data. You get it every 5 minutes. This is what we provide automatically to INCOIS. They use it for their warning purpose. This is very important critical data which has to come. And INCOIS and NAOT, we have got a national committee. These buoy systems are specifically positioned, 5 of them in Andaman Nicobar near the Nicobar Plateau, and 2 of them are near Makran. There are about 60 minutes travel time, 30 minutes travel time. There is a particular calculation involved in strategically positioning that. Now, what have we done in all these years? There are about 13 odd countries. They have been using these similar such systems, and India has developed our own system. I'm proud to say that our Indian system, we call it as Sagar Bhumi, which is completely made in India. That has been very cost effective, and we are sharing the data in an effective manner. So this is what is the current system which is working. The whole group does many other activity like similar for mid-ocean and cyclone warning. We have similar systems. So we have a state-of-art facility. There was a question during the COVID time. Yes, whenever there was a breakage in the reception in cause in NAVT, we were functioning continuously even during the COVID time. Thanks to the people, even we sailed out 3 cruises. Recently, we went to Arabian Sea and we have installed the system. Now next week we'll be sailing to Bay of Bengal to service and reinstall back. We have a data reception facility. What you have seen at the bottom, both tsunami as well as the mid-ocean data is continuously transmitted. What we need to have to install is a specific ship, and that has to go there and that have a longer endurance. We need to survey the bottom, the near to the tsunami zone. The bottom may be very have an undulation, so we have to specifically install over there. Some of you may be engineers. I thought will show how the data telemetry takes place. Everything is automatic, and the data from NAOT goes to from the buoy, as I showed earlier. It comes to NAOT. From NAOT, it goes to INCOIS. From there, we share the data with the National Database Center under the UNESCO IOC agreement in the globally. This is what my another role as a chairman of International Tsunami Partnership. We are working with many other countries and we are sharing the data. I've shown many countries, 13 countries. Most of them are using the DART system made by PMEL and transfer to technology to an industry. India is one country. We are able to make our own system and we are also providing the global data format. Now, having seen this, we also developed a new wherein why can't we have the whole system submerged? Because the transmission may not be there, somebody may not disturb it. There are some practical difficulties globally keeping the surface buoy system functional. This is our own patent where the whole system will be submerged. When there is a tsunami event, it pops up. So we have done the initial testing and trials. There is a global need and many other countries are interested to know about this particular new system which we have developed. Once it is ready, we will be transferring the technology. This will ease out many of our difficulty for having the system sometimes surface which may get damaged. So the whole thing is that it has to work in a particular moment. We cannot say that in that moment the system did not work. So we have redundancy. With this experience, we have formulated it. The bottom right, the students may refer. There's a book we recently published which talks about all the observation tools and techniques what I have been presenting it here. There are also challenges we need to understand about it, keeping a system for a year or more than a year in the sea bottom. We had a unique case where one of our tsunami buoy system at 3,300 meter depth, close to Nicobar, had some sort of, bottom right you can see, on some sort of mucus substance. So we were amused what could be the smelling. Then we referred to Dr. Henry Daman, who has been working on the Titanic shipwreck, which has sunk more than 100 years ago. She had published that next 20 years down the line, microbes can eat away this large structure which is lying on the seabed. We all know the importance of COVID. What microbes can do it. We live in a biosphere. Yes, there are something can happen. So herein we found that any of the uncoated material, even though they are corrosion resistant stainless steel alloy, that got damaged. This is an important finding. The whole system would have been lost if you have not retrieved it. So these are all the challenges when you work at sea. We need to understand about it. Now, going back to the future, this is one of the recently I was sharing one of the session on deep ocean observing in ocean science community. Therein, Dr. Ariyoshi from Jamstack, he had come and presented. Japan is doing wonderful work on technology development. They are drilling the seabed. You can see they have a special ship Chuku which can go and position it, and from the seabed 2 kilometers deep they can drill. This is what the picture talks about. They have drilled and installed a seismometer as well as a temperature and conductivity sensor that is being transmitted in real-time mode. So this is to talk about, there is a lot more thing. They also have got a remotely operable vehicle. So there is a way in ocean where you can go and precisely drill and put a sensor. Srinivas mentioned about cables. I'm also part of this joint task force comprising of International Telecommunication Union, World Meteorological Organization, and IOC UNESCO. We are trying to work. There are about 1 million length of cables. We all are using mobile. The current internet depends on the underwater cable. Even Chennai to Singapore, there's a cable. From Bombay, many other cables are there. Andaman to Chennai, another cable is being laid by Government of India. There's one more cable recently Cabinet has approved from Cochin to Lakshadweep. So whether we can use this telecommunication cable, which are working on fiber optic principle, so that there is a large amount of data transfer is possible in this way. So this is what the global community we are discussing. ITU is working very closely and part of this International Tsunami Partnership. There's a technology component is there. The sensor should work for 20 years because these cables would remain on the seabed for 20-25 years. Having seen the cable recently, Mrs. Sundar Pichai, CEO of Google, he has announced that the Google has made a new effort to talk about earthquake detection by having these cables. Google has got about 16 cables worth of $16 billion. They own the data. When the cable is laid in the land part of it, when the cable is exposed, Nokia has developed a small tool which converts the optical to electrical. The other way around, when it gets into the water, it's the other way around, electrical to optical. So what they do is that they continuously monitor any other aberration, any other signal, particularly mechanical signal, they get it. This normalcy is very calm, it's absolutely. But there are cases where they get aberrations. They approached a professor from University of San Diego. He has given a model and algorithm which, as Google had worked on it, they found out in two cases they were able to detect the underwater earthquake. This is amazing. There's no specific sensor. Using the existing data, they were able to detect. This is what Dr. Sinivas also mentioned. We have been talking about earthquake-based tsunami. There are also non-seismic tsunamis could happen, which happened in Indonesia. Our colleagues have shared about it. There could be landslide or meteorites. So what could be done? This is what in the data by cooperation panel we discussed. We proposed to have an workshop inviting experts from different disciplines to think differently. The current technique of using the water level record is exclusively for earthquake detection, but something more can happen over there. So still we are not understood much about the earth, what we are living. We are trying to know more about Mars and Moon, but having the importance we have discussed on the disaster, how it can affect the coast, particularly in our area where about 1/5 of the population is living. So there's a need to understand about it. Maybe next year we plan to call all these big industries and as well as seismologists, geologists, computer specialists, data analysis students to have a different discussion about it. So in future, tsunami will remain as a major threat to the coastal infrastructure and the human life. So it is utmost important for us to advance our understanding of all aspects of tsunami research. So we are trying to focus globally. Tsunami research should be prioritized now. Even the UN Decade of Ocean, there is a discussion about that, and apply our knowledge for the early warning direction. That is what we are talking about it. And assessment and mitigation tools are to be done. So I'm sure that such workshops will pay away, bring newer thinking, and we will be able to succeed in trying to help the society. Thank you very much. Pranam to Ma.
Thank you very much, sir, for that wonderful presentation. It was very wonderful to hear about an aspect, a very important aspect in disaster risk reduction, namely observations. And we feel privileged to be able to see the pictures that were taken and the data that was taken from the ground zero in 2004 tsunami. I'm sure that all the students very much got excited by your presentation. And they will will have questions for you. But sure. As of now, is there any question?
There's a question somebody has asked. Can you read it? It's there in the chat box.
Sure. There's actually a comment, Dr. Venkatesh.
Yes, please.
That you have given a wonderful, marine engineering, amazing work, integrating with large number of disciplines, including microbiology, going on in NIOT. Great.
Thank you very much. Yeah.
My comment is from Dr. A.S.K. Nair.
Thank you, Dr. Nair.
I had a question.
Yes, please.
Please go ahead, ma'am.
So I had a question when you have talked about the new system where the new patent which you were talking about, where the boys remain under the sea.
Yeah.
And whenever it is required, it basically comes up. And I had the question with respect to sustaining the power. How are we doing?
Yeah.
And also to cover this large area, how many buoys we need to cover this large area for tsunami detection?
Fine. We have two for tsunami-genic fault zone, which Dr. Srinivas also covered. So initially, there is a national committee comprising of seismologists and geophysicists and geologists. They have identified we need about 5 of them. And also an important part is that INCOIS also shares the data with the neighboring countries. They too have deployed similar such systems close to the fault zone. We need about 2 for the Makran region. And an important point is that we can deploy the systems either in the outside the EEZ or open ocean or within the EEZ. There are also limitations for us going close to the other countries' EEZ. Keeping that in mind, we would like to maintain the same system. Coming back to the power consumption, it's a very valid question you have asked for it. We are using lithium-ion battery. Basically, even our main buoy system, we need about 3,000 ampere hour. So they are working very fine. And the important point is we submerge it to 300 meter water depth. That is a level up to which there are chance of fishing net can get entangled. Now, what we are trying to work is, can we think of an underwater winch which will pop up and pull it down? Without winch, it's very easy. With winch, is very complicated. Without winches, it will come once. And from our past data, we can clearly say that how many times it need to pop up. So we can program in such a way that it gets triggered and pops up to the surface. But we are also working in the next level, whether it can have a winch to that. Winch is a system by which you can pull it and bring it back. So we have done a test of Goa and Arabian Sea. It worked. So now we are fine tuning it.
Thank you very much, sir.
Thank you, sir. Thank you, madam.
Thank you very much, sir.
Thank you. You mentioned Doctor, you're talking about communication. The biggest challenge for us is using Inmarsat communication, which is geostationary satellite. Recently, we got the approval to use Iridium, which is LEO. Then there's a power consumption will be 1/10 of it. So once it comes through, this will be much better. And we are also working with ISRO. Maybe 4 years down the line, we'll have a INSAT, which will have a coverage and footprint to the ocean, and that will be similar to the one what we are using. So maybe another 4 years down the line, the completely whole thing can be communicated through INSAT. Presently, we do the platform encryption, so that's what we work on. Thank you.